It can be argued that we Earthlings do not appreciate our home planet as much as we should. It is incredibly important to understand how precious the Earth is. Scientists have been unable to find another planet like ours even after decades of searching. While life on our planet thrives in unexpected places, it is nowhere to be seen elsewhere in the universe. However, new reports state that NASA has discovered two super-Earths that may have the ability to sustain life. Let's take a closer look. It's kind of amazing to realize that in the past couple of decades, we have confirmed detections of over 4,000 exoplanets, or planets orbiting other stars. This is but a tiny fraction of the estimated trillion exoplanets roaming the Milky Way galaxy, but it's still way better than we had in the 20th century. As soon as astronomers started finding exoplanets, they realized what a wonderful zoo we live in. Planets orbiting dead remnants of stars. Planets bigger than Jupiter orbiting closer to their star than Mercury does the Sun. Planets so hot that they rain lead. Purple planets. And the super-Earths. Rocky planets slightly larger than the Earth, orbiting within the habitable zones of their parent stars, the place where liquid water can potentially exist on a planetary surface and where life like our own has the best shot of surviving. First, we have to be clear about what we mean by habitable, as some wild worlds in our solar system stretch far beyond what we would consider normal. After all, no other known planet is quite like Earth. The other small rocky planets in our solar system are either barren wastelands or nightmarish hellholes. The gas giants, with their deep crushing atmospheres, are ruled out. That means that, in our survey of super-Earths, we need to find planets that look and act a lot like our planet. This includes sitting within the habitable zone of a star to make sure the temperatures are just right, as well as having atmospheres that are relatively thick but not too thick. These planets also need to have liquid water on the surface, not locked beneath a frozen crust or boiled away into a vapor. And lastly, they must have a magnetic field to protect that atmosphere and liquid water from the constant, brutal onslaught of the solar wind. There are a lot more criteria that need to be in place for a world to host life, but without these base conditions, the chances of something growing in an alien world are pretty slim. Astronomers generally define a super-Earth as any planet between the size of Earth and 10 times more massive. Astronomers tend to call planets larger than that mini-Neptunes, but that clean distinction disguises a lot of nuances that are important for determining habitability. Something closer to the size of Earth has a better chance of being habitable because, presumably, it's very similar to Earth. And something closer to the size of Neptune probably would not be a very fun place for life to find a foothold because Neptune in general isn't all that hospitable. As planets go up in mass, a rocky core gets better and better at hanging onto a thick, gassy atmosphere because of its enhanced gravity. Eventually, there will be so much atmosphere that the planet would be better characterized as a gas giant than a rocky world. Unfortunately, we lack a clear dividing line between those two extremes, and super-Earths bridge that gap. This is where the orbit matters too. If a planet is too close to its parent star, regardless of its size, it's just going to get roasted. Ultimately, a habitable super-Earth needs to have the right density, indicating that it's not too rocky or too gassy. Even then, it's only a guess, as astronomers have scant information about any particular exoplanet. As for the magnetic field of any exoplanet, this is a matter of pure speculation. Scientists think planets larger than Earth are likely to host strong magnetic fields, but it's impossible to know for sure. For example, while Venus and Earth are roughly the same size, only Earth has a substantial magnetic field. Many of science's greatest mysteries surround questions of how much life is in the universe and what forms it might take. And given the popularity of sci-fi movies depicting alien creatures, interest is not limited to researchers alone. For millennia, great minds have contemplated the origin, nature, and prevalence of extraterrestrial life. But despite the impressive brain power brought to bear, the frustrating reality is that we don't know who or what is out there. Scientists have good reason to think billions of inhabited worlds are sprinkled throughout our galaxy in a universe teeming with life, perhaps even technologically advanced life. But maybe the genesis and long-term survival of life on Earth has been a once-in-a-galaxy fluke. Maybe we're living in one of the precious few miracle worlds where life evolved to staggering levels of diversity and complexity. Scientists can debate these questions until they're blue in the face, and they have. But the only way to find out the definitive answer is to observe and explore. And here's the good news. Never before have scientists had so many tools at their disposal. excitement is palpable that in 10 to 20 years, astrobiology could make the critical leap from theory to direct observation, no longer suffering the ignominy of being a science whose subject matter is not proven to exist. Although there's no official competition or roadmap, scientists across multiple disciplines are pursuing three general pathways for detecting extraterrestrial life. First, they're hunting for life in the solar system using robotic or sample return missions. Second, they're searching for compelling evidence of life-bearing worlds by probing exoplanet atmospheres. Third, they're chasing the ultimate jackpot, evidence of intelligent life through purposefully seeking out alien signals or receiving them by serendipity. A major challenge in any search for life is defining exactly what we're looking for. Terrestrial life assumes such a dizzying variety of forms, from acid-loving bacteria to kangaroos, that attempts to define it inevitably leave out entire classes of critters. Plus, what's out there in the greater universe might be even more extreme than anything we can imagine from our limited geocentric perspective. In their recent book, Imagined Life, planetary scientist Michael Summers and physicist James Trefil identify three kinds of life: life like us, life not like us, and life completely different from us. The first centers around all terrestrial biota, such as life that is based on organic chemistry using liquid water as a solvent. The second involves chemistry based on elements other than carbon, such as silicone. The third is the wild card: life forms so far outside our conceptual horizon that we might not even recognize them as being alive. Scientists are familiar with the first type of life, so they have some idea of what they're looking for. Better yet, solar system exploration over the past 5 decades has greatly increased the inventory of relatively nearby candidate worlds that might harbor some form of familiar biology. Mars remains the most compelling target due to its proximity and overwhelming evidence that liquid water once covered much of its surface. Finding life on Mars would be a monumental breakthrough. If that life turns out to be similar to that on Earth, it would imply that either it was transported inside a meteoroid from one planet to another, or that both worlds were seeded from a common outside source. It would be amazing to learn that planets can exchange life and that terrestrial life might have originated on Mars. But if Martian life has a different chemical makeup, is not based on cells, or utilizes information encoding molecules other than DNA and RNA, it would strongly suggest that life originated independently on 2 different worlds and took 2 different paths. This would then imply that life is widespread in the galaxy. Humanity has long focused on Mars as the most promising abode of life, but interplanetary probes have greatly expanded the list to include worlds that might contain liquid water oceans beneath their icy facades. Calculations by scientists at the University of Arizona suggest there could be as many as 12 to 15 solar system worlds that harbor subsurface oceans. These include planets, moons, and even Kuiper Belt objects such as Pluto. Life on such worlds could resemble the myriad bacteria, tube worms, clams, and other life forms that thrive around hydrothermal vents on Earth's ocean floors. These creatures draw their sustenance from nutrients expelled by the vents, not from sunlight. The icy shells of Europa and Enceladus are relatively thin. In 2005, NASA's Cassini spacecraft returned spectacular images of jets venting salty ice particles into space from Enceladus's south polar region. And in 2014, the Hubble Space Telescope first spotted evidence of plumes emanating from Europa's south pole. In 2019, researchers released the best evidence yet that Europa's plumes contain water. All these discoveries suggest that biogenic materials could exist at or near the surface. An international team of astronomers has discovered 2 new super-Earths orbiting a distant ultra-cool dwarf star located 100 light-years away from Earth. The newly spotted exoplanets orbit the second coolest star ever found with planets around it. The inner planet of the system, designated LP 899b, is around 30% larger than Earth and rapidly orbits the dwarf star in just 2.7 Earth days. The second planet, called LP 890-9c, is slightly larger, at around 40% larger than Earth, and completes its orbit in around 8.5 Earth days. Astronomers believe this second planet is in the habitable zone of its star, where it is neither too hot nor too cold to support the existence of liquid water at its surface. The inner planet was originally identified as an exoplanet candidate by the Transiting Exoplanet Survey satellite, which spots exoplanets as they cross the face of their stars, as seen from Earth, causing a tiny drop in light output. It was then confirmed by telescopes of the Search for Habitable Planets Eclipsing Ultra-Cool Stars project operated by the University of Birmingham in the UK. The Speculus team then searched the system for additional exoplanets, which revealed a second world that TESS missed. TESS searches for exoplanets using the transit method by monitoring the brightness of thousands of stars simultaneously, looking for a slight dimming that might be caused by planets passing in front of their stars. However, a follow-up with ground-based telescopes is often necessary to confirm the planetary nature of the detected candidates and to refine the measurements of their sizes and orbital properties. This follow-up work is particularly important in the case of cool stars like LP 899 because much of their light registers as infrared, to which TESS's sensitivity is limited. That weakness isn't shared by the Speculus Project telescopes, which are located in Chile and on Tenerife, an island just west of Morocco. These telescopes are equipped with cameras that are very sensitive to near-infrared light. The goal of Speculus is to search for potentially habitable terrestrial planets transiting some of the smallest and coolest stars in the solar neighborhood. This strategy is motivated by the fact that such planets are particularly well suited to detailed studies of their atmospheres and the search for possible chemical traces of life with large observatories such as the James Webb Space Telescope. Scientists compared the discovery of these planets around the cool star LP 899 to finding the exoplanets of the TRAPPIST-1 system, centered on what is currently the coolest star ever found to have planets orbiting it. Of the 7 known exoplanets around TRAPPIST-1, 3 are in the habitable zone, which has made the system a prime target for deeper investigation. And the fact that one of these newly discovered worlds occupies the habitable zone of LP 899 makes further investigation of the system almost equally enticing. This gives astronomers a license to observe more and find out whether the planet has an atmosphere, and if so, to study its content and assess its habitability. Next, the scientists hope to study the atmosphere of Speculus 2c with the JWST. If you like this video, please check out this one, which talks about the JWST and how it may have detected signs of life on Proxima b. Do you think life is possible on these newly discovered super-Earths? Please share your thoughts in the comments section below.